Currently pursuing my PhD at IIT Madras in the Department of Chemical Engineering at IIT Madras. So today basically I will be talking about characterization of beach plastic waste by analytical pyrolysis, gas chromatography and mass spectrometry. So as we will know, due to unique feature and characteristic of plastic like durability, lightweight, ease of manufacturing, so it has been become inevitable material of our day-to-day life. But due to non-biodegradable nature and toxic chemicals present in the plastics, it has been created a concern to the in the terms of climate change and ecosystem loss. So as we can see, like 1 ton of plastic can produce up to 2.5 tons of carbon dioxide emission, and you can see that out of since 1950, the introduction of plastic, we have been produced 8.3 billion tons of plastic. So out of which very few globally, if you'll see, 9% has been recycled and 12% has been burned to energy. It has been combusted to get energy recovery, and the rest has been landed up the open dumping, and which is ultimately landing up in the ocean. And further, by landing up in the ocean, so these plastics has not been become completely biodegradable. Due to this physical, mechanical or biological degradation, this bulk plastic has been degraded into smaller and smaller 5 gram atom, so which are known as based on their size range, it has been till for the till now that by National Oceanic Atmospheric Administration, there has been size has been devised by the microplastic. It has been the size less than 5 millimeter. So based on the size range, also types of sizes available, like it can go to microplastic even go below to nanoplastic. So due to this bulk abundance of microplastic, if you'll see in all the matrices, it has been available due to non-biodegradability, all this polymeric material. So if you'll see in the basically from this microplastic abundance, basically marine organism. If you'll see annually, 1 lakh marine animal or seabirds has been killed due to this microplastic ingestion, due to starvation and leaching of some chemicals. So there has been, so why we as a human being worried about to study about this microplastic? If you'll see, as a part of study has been, there has been reported literature in the tap water, honey, beer, and where the food intaking in seafood, also the presence of microplastic has been reported. So we are also ingesting microplastics, but till now, so the effect of in long term, the effect of these plastic particles has not been till now. It has not been resolved. So as a part of study, yeah. So again, for this microplastic identification in all the matrices, if you'll see, so the method varies from matrix to matrix, like soil, air, or biota, sediment, water. So there are various methods has been used for to extract microplastic and their identification. So among all these methods, there are one is destructive microscopy techniques we have used, destructive techniques and non-destructive techniques has been used. So microscopy techniques helps in identify their size, shape, and color distribution. And from this spectroscopy techniques, we can identify their functionality presence in that particular microplastic. And if you'll see, based on this from the literature, the reliable and this thermal analytical methods has been widely used. So apart from size, we can actually identify what is the originality of that polymer and what is the composition of that polymer using this thermal analysis techniques. So from there many method, you cannot use single analytical method. So you have to use combinedly along with one method spectroscopy techniques, other with another method, so that we will get along with physical characterization, we will get chemical characterization data. So as you know, so till now for like plastic waste management, we have there are methods landfilling method, which has been causing concern, recycling and incineration. So from this recycling method, there are various methods. So which is called thermochemical conversion. So based on these, there are combustion, pyrolysis, and gasification methods are there. So, like in terms of pyrolysis, based on their carbon footprint and their wide ranges of product profile we are getting and cost-effective approach among combustion and gasification, pyrolysis method has been widely used. So again, from this pyrolysis method, we can it can be used as a analytical pyrolysis method, which where you will use very few microgram of scale of few micrograms sample in that range to determine the quantity identity of that originality of the material and the decomposition of that material. And in the applied case, we can use in bulk sample to convert all those plastic waste into valuable chemicals or monomer recovery or valuable chemicals to convert into on this plastic waste. So as a part of my study, basically I will not talk about microplastics. So as a part of today's talk, I have like collected these beach plastic waste. So basically, you cannot say these are microplastics. So these are basically Chennai sea beach. I have collected these all these plastics. You can say these are the fragmented from the bulk plastic waste. So I have collected randomly all these plastic waste. Like I don't know like for how long these has been exposed to the sun and water. All this. So I have collected this already 19 samples. So all these 19 samples I subjected to thermal gravimetric analysis, FTIR, and PIGCMS analysis. So from this 19 metrics of sample, so from these three techniques, I got, you can see these are the polymer distribution I got from the for the this 19 waste plastic. So as you can see from this, 43% and 21%, like this belongs to polyolefinic plastic waste. As you can see that these polymers are like widely used for the packaging materials, and rest of the things has been polyvinyl chloride, polyurethane, polystyrene, polystyrene, or mixed plastic. So and this is the polymer distribution waste plastic. So again from this I just from this matrix of plastic, as I saw that polyolefinic plastics are contributes more in percentage. So I thought of to see the any behavior of this because all this plastic has been exposed to the open environment a longer period, to see the effect of any all these same polyolefinic plastics. So I just focused on the study on this sample ID. So these waste plastics are belongs to polyethylene. After pyrolyzing the sample using analytical PyGCMS, so based on their analysis, I came to know these are all these polyethylene sample. So these are all like I subject to ultimate analysis. So I got this carbon weight percent, hydrogen weight percent, and their calorific value. So you can see like these are these are all made up of fossil fuel and natural gas. So obviously their carbon and hydrogen content I got more, and it has all this like 35 to 40 within that 40 to 50 heating value. This range of all this waste plastic has. So yeah, so I narrowed down from this matrix of 19 plastics I to polyethylene plastics. So to this subject to thermogravimetric analysis. As you can see, so these are all polyethylene samples. So again, in polyethylene, you will get types of polyethylene based on their application: LDP, HDP, LLDP, and ULDP. So I got this degradation temperature range for all these profile. For some, like all we got, say for all of the polyethylene sample, I got single stage degradation. But for some, like if you can see S7 and for S11, I got two stages of degradation. So these are due to the heterogeneity of the sample. So and based on the literature, these temperatures I got these are falling within the range of polyethylene decomposition temperature. And coming to this ATR FTR analysis for all these polyethylene sample, as you can see for polyethylene, these are the for all these polyethylene sample, I got this at the wave number CS tracing 2845 and CS2 bending at 1464 and 715. These are same about the for all the polyethylene sample except this S7. So this is due to the presence of other chemicals or additives present, might be due to this. These are belongs to I got a CO stretch and C development stretching or OH bending. So then come to like after this TG and FTR analysis, I subject to PYGCMS using multi-sat frontier prioritizer. So coupled with GC and MS quadruple detector. So there so here what I can do, like you can do with that multi-sat, that same sample polyethylene. Here I took the sample amount within 100 to 200 microgram range, and I saw that same sample you can do two analysis. First, in first program, you can give the thermal desorption analysis, and after thermal desorption, the same sample will be dropped to pyrolysis region. So this is the benefit of the double shot. What? So at this is called thermal desorption range. You can see this is TD chromatogram. So whatever in this is called, or you can say sub pyrolysis temperature. So the temperature range will be 100 to 300, 320, maximum 100 to 350. So at this there will be no pyrolysis, only thermal digestion. So in this range, whatever the like unreacted monomers or solvent or additives, those will be, or low molecular weight compounds, what will be present in that sample. So it will be come out in this region in thermal digestion range. So again, after that, if you directly subject to this pyrolysis, all these will come at a single chromatogram. So to avoid interference from the complex environmental sample, so this will be useful. So first, all the so these compounds will not be interfere in pyrolysis. So as you can see, all these compound I got in thermal digestion range, and after I subject that same sample to pyrolysis, which has been happened at 600 degrees centigrade up to 30 seconds. I got all these for polyethylene sample. I got these are the like if you pyrolyze polyethylene, you will get the triplets of this chromatogram, which is alkadine, alkene, and alkane, followed by this double bond low molecular weight olefin like pentene, hexene, heptene, and octane. So this is the I got overall distribution of this waste plastic like for polyethylene. What are the like in thermal digestion regime? I got most of this. If you can see this here, the carboxylic acid area percentage is more, because some of the samples are like over the period some compounds has been adsorbed to the sample, and some sample has oil content. So this belongs to this carboxylic acid. These are like these includes like tetradecanic acid, hexadecanic acid, pentadecanic or octadecanic acid. And if you can see the in pyrogram, which is carried out at 630 degrees centigrade, so alkane percentage is more. So because these are made up of polythene, so it has been happened, the pyrolysis has happened due to like due to thermal cracking, like end chain scission mechanism has happened. And beside all this like marker and alkane alkadine triplets, some of the other like alcohol and ester I got, these are due to presence of some oxygen, might be due to oxidation of hydrocarbon. So this compound has been formed in pyrogram. So coming to conclusions, I did thermal decomposition range, all are like belongs to polyethylene, and ATR FTR analysis I got that also confirmed polyethylene, and ultimate analysis this elucidated these are rich in carbon and hydrogen content. So and in thermal digestion, I also observed some phthalate compounds. Those are has been added to plastic while manufacturing to give desired product. And from the matrix of plastic, these are the like more of the polyolefin plastic I got. Like you can see more than 70% I got polyolefinic acid, and rest of the polymer belongs to polyurethane, and 15% equal to polyvinyl chloride, polyester, and PS respectively. So based on like you can see, these are the like from ocean plastic waste if you see. So this is a high potential we can recover, like if you see for polyolefin plastic, like we can like based on for further we can like vary like catalyst, or based on varying the temperature or operating condition, we can recover some this low molecular weight monomer, which can be again reused as like for feedstock chemical production. So yeah, so this ocean plastic can be a source of to get valuable chemicals and other things. So finally, I thank to the SG Lab Forum and whole team for giving me opportunity to share my study. Yeah, thank you.
Yeah, thank you, Shivan, for the nice presentation. At least your talk was like basically using the board technique, what we have discussed the whole day. So I think I do not see any questions from the dais, like audience for any of the speakers? Maybe people are tired and they want to like move to the panel discussion. So definitely there are opportunity tomorrow and day after tomorrow, and all audience know your name, so they can always connect with you through like a one-to-one chat. Okay. So let's all move to the panel discussion session. So I will do the transfer. So thank you all for your contribution to this session. It was a wonderful session. Okay. So we will see you all in the panel discussion.
Okay. Thank you.
Thank you.